Today we're going to look at graphing linear equations, just some basic principles of it, and just looking at what a linear equation, what makes up a linear equation. So first of all, linear equation in two variables. The standard form that is used for a linear equation looks like this: ax plus by equals c. That is the standard form for linear equations. So all you really need to know here is that a, b, and c are real numbers. And then the x and y both have an exponent of just 1. And this is a standard form, and typically we see things in like slope-intercept form, where that would look like this: y equals mx plus b, but we'll save that for another video. But you typically see an equation like that, but this is the standard form. And if an equation is able to be in standard form, ax plus by equals c, then we know it is a linear equation. So let's look at some examples where we're going to identify linear equations based on that sole fact of, can we write it into standard form? If we can, then it is a linear equation in two variables. So the first one, letter A, x minus 2.5y equals 1.1. So the a value here, if we're looking at just like ax plus by equals c, the a value would be 1 because it's 1x. The b value would be negative 2.5, which is okay. Could have a decimal there. And then the c value would be 1.1. We have x to the first, y to the first, so then we would say yes, it is a linear equation. Meaning if we were to graph it, it would make a straight line. Linear equation makes a straight line. Letter B. Now don't let the form throw you off, because if sometimes you could rearrange the terms, move things around, and get it into standard form. So if I take that idea of, well, I'm going to add this 3x over, that will give me ax plus by equals c. So I can move over that 3x, and that now becomes 3x, where a is equal to 3, b is equal to 1, and then my c is equal to 0, which is fine. I could have a c value of 0. That's completely fine. So this one is also yes. I could write that into standard form. Letter C, x plus y squared equals 4. So we do have an ax, an a value of 1, x to the first, that's fine. But then we get to the y value, and that b value would be 1. But look at my y value, y squared. So the exponent would be squared. That is not going to be a straight line. It is not an equation that we could write into standard form because it's not y to the first. So then that would be a no for that one. And this one, letter D, is just 3. I'm going to modify that. I think I was supposed to write x equals 3 there. I think I just forgot the x equals. So x equals 3, which is a standard form. Because if you think about the terms, this is 1x, a is equal to 1. And I don't have a y, but I could rewrite this as x plus 0y equals the c value of 3. So 0y, that's okay. We don't need a y present because the b would be 0, and 0 times anything is 0. So really I just don't even have that term, but it's okay because the b value would be 0. 0 is a real number. So that would be yes. If I were to graph the equation x equals 3, it would form a straight line, which this is written in standard form. So let's practice graphing the linear equation. And for this video, we're just going to look at this as creating a table and just generating a graph completely on our own. So we have the equation 3x plus y equals 4. So what I want to do is I want to grab some x values, and then I'm going to plug it into this equation, 3x plus y equals 4. And my results will have a y value as a result. And then we'll create an ordered pair of x, y. And then that will go onto our graph. So let's just take some x values. And there really is no right or wrong with x values that you pick. It's just generating the graph. And typically, you get an idea of just looking at the equation of where you want to center this. Like, we're completely fine just grabbing a couple negatives, 0, a couple positives. But that's typically what I go with. I just grab a couple negatives, 0, and a couple positives. But I'll just go with -2, -1. I'll stretch this first one out, and then I'll try to shorten up the rest of them, and we'll just do this. So we'll do -2, -1, 0, 1, and 2, just to get the full picture of what's happening here. And then from here, it's just taking these x values, plugging them in for x, so I'll have 3 times -2 plus y equal to 4, and then I'll have 3 times -1 plus y equal to 4, and then we're just solving for y on all these. So on the first one, 3 times -2 is -6, plus y equals to 4. Didn't give myself enough room to write. Plus 6, y is equal to 10. So the y value here is 10, meaning our ordered pair would be -2, 10. And I would take that ordered pair, plot it on the graph. So -2, 10 would be right here. And this would continue. So next one, 3 times -1 is -3, plus y equal to 4. I got to add 3 over. Y is equal to 7. So I get the ordered pair, -1, 7. Put that on the graph, -1, 7 would be right here. Next one, 0. So 3 times 0 plus y equals 4. So 3 times 0 is 0. So I just have 0 plus y equal to 4. 0 plus y is y. So y is equal to 4 on that one. Not really much work to do there. So 0, 4. A couple more. Let's go through these quickly. 3 times 1 plus y equal to 4. 3 times 1 is 3. Plus y equal to 4. Subtract 3. Y is equal to 1. So the ordered pair is 1, 1. And last one. 3 times 2 plus y equals 4. 3 times 2 is 6 plus y equal to 4. -6 minus 6, y is equal to -2. So we get 2, -2. And then we connect the points, making a perfectly straight line, which I can do very easily with no assistance. There it is. There is our line. So we're able to generate this line purely from taking x values and plugging them into the equation, and out comes a y, and then we get a set of ordered pairs. Now the challenge though with this is just understanding how to take some x values and what are some good x values to pick. There really is no right or wrong. So I'm just going to go through a couple more examples here. So look at this one. Think about this one and what would happen. So it's always good to look at these equations and try to just like mentally go through some x values and get an understanding of what happens if I plug in this x value or this x value, like a positive or a negative or even or an odd. Because what's going to happen here is at some point I'm going to have to divide by 2, right? Because in order to get the y by itself, that's what we've been doing, I'm going to have to divide by 2. So the operation here is I'm going to have to subtract the x value, whatever I come up with is the x value, I'm moving that over to this side, and then I'm going to have to divide by 2. So what I want to think about is trying to keep my number over here an even number. Because if I have an odd number, let's say I work through this and I get 2y equals 9, I'm going to divide by 2, that's going to be a fraction. 9 over 2 is going to be a decimal, it's going to be a fraction, not the easiest ordered pair to graph. So if I keep my value over here an even number, since I have to divide by 2, then that will make the graphing process that much easier. So think about x values that we can plug in that would keep the result over here an even number. So let's do like -2 is completely fine. 0 again, completely fine, because we already have an even number over here because it's just 6. And then let's just go with 2. So I'm just going to grab a couple, -2, 0, and 2. So the x value of -2 plus 2y equals 6. I'm going to add 2 over to both sides. I get 2y equals 8. Then I divide by 2, y is equal to 4. So the ordered pair that we get here would be -2, 4. Right there. Next one, 0. So 0 plus 2y equal to 6. 0 plus 2y is just 2y equal to 6. Divide by 2, y is equal to 3. So that ordered pair would be 0, 3. and the x value of 2. So 2 plus 2y equal to 6. Subtract 2. 2y equals 4. Divide by 2. Y is equal to 2. So the pair there is 2, 2. So right there. I only grabbed a couple just to keep this video relatively short and not super long, where I don't want to grab like 5 for every single line that I'm going to do here. But this just gives us the idea. It's always good to get like 3 or 4 to 5 points. And this gives us a really good scope of what this line is doing. So the challenge with this one is just seeing that pattern of like, well, I want to try to keep that number even because I have to divide by 2. So it's something to look ahead at. And you could always just solve for y in your equations and then you don't have to worry about it. Let's move on though. So this next one, a little bit more difficult to do that because we have this negative 4x plus 3y equal to 12. So here's how I would go about approaching this one. So let's grab some x values. The equation here is negative 4x plus 3y equals 12. Y values in our ordered pair. So what we want to have happen is we want this number to be divisible by 3 because I want to divide by 3. So to start off, just think about numbers that multiply, that 3 even goes into. So like 3 goes into 12. So I know I could use 0. 0 is a good value to use. So I'm just going to write down 0. 0 is a good value to use for my x values because if that's 0, then that's going to be negative 4 times 0, which is 0. So I'll have 3y equal to 12. So that'll be able to do that, no problem. And then what else? Well, what if I do like 1? Well, that'd be negative 4 times 1, which would be negative 4. And then I have to add 12 plus 4 is 16. Not going to work. So then I would just go through that kind of process and just wait until you get to that moment. But it's really not that crazy because if you just do 3, that's negative 12. And then you add 12. So we could do that. So you could even do negative 3 and positive 3 and see what happens. Just kind of curious to see what happens there. So I'm going to use 0. So negative 4 times 0 plus 3y equal to 12. Negative 4 times 0 is 0 plus 3y equal to 12. Divide by 3. Y is equal to 4. So the ordered pair here would be 0, 4. Next one, we said negative 3. Let's try that. So negative 4 times negative 3 plus 3y equal to 12. That's going to be positive 12. Negative 4 times negative 3 is positive 12. Plus 3y equals 12. Subtract 12. Okay, 3y equals 0. 12 minus 12 is 0. Divide by 3. Y is equal to 0. So the ordered pair here is negative 3, 0. Interesting. Negative 3, 0. And then last one, positive 3, we said. So negative 4 times 3 plus 3y equal to 12. And that would be negative 4 times 3 is negative 12 plus 3y equal to 12. Add 12 over. 3y equals 24. And then that divided by 3. Y is equal to 8. 8. So 3 eighths. 3 eighths. Where am I at here? 3 eighths. There it is. Now we have our line. Yeah, definitely a little bit more of a difficult one on that one. I can't move it over. Because you really have to be careful with your x values. You really have to get an understanding of how these numbers interact with one another and get an understanding of, like, if I tried 1, that would be negative 4 times 1 plus 3y equal to 12. Negative 4 times 1 is negative 4. If I add 4 over, that's going to be 16. 16 divided by 3 is messy. Not easy to graph. So that is why I did not just go through like 1 and 2 and negative 1, negative 2. Try to get numbers that create a scenario that is favorable, meaning divisible by 3 in this case. So moving on. This one, a little bit easier because we already have the equation saying y is equal to negative 2x. So if we take some x values, we really don't even have to like think too much because it's just y is equal to negative 2x. So whatever x values I choose, I'll be okay. So I like to do negative 2, 0, and 2. And I'm just plugging this into y equals negative 2x. So y is equal to negative 2x. Let's do negative 2 times negative 2, which is positive 4. So the order pair here is going to be negative 2, 4. Plug in 0, so negative 2 times 0. Negative 2 times 0 is 0, so that comes out to be 0, 0. And then x is equal to positive 2. So negative 2 times positive 2 is negative 4. So the order pair there is 2, negative 4. So let's go ahead and plot that, 2, negative 4. And here's our line. The points are way off. That's okay. Let me redo that one. Okay, a little bit better. A couple more examples. Graph the linear equation y equals negative 1/3 x plus 1. So here we have a fraction. So we really want to pay attention to what x values we choose here. We really want to be careful here with these x values. So I have this fraction y equals negative 1/3 x plus 1. And remember, if you have negative 1/3 x, that's the same thing as negative x over 3 plus 1. Like you could just put that x over 3 like that. So what I want to do is I want x values that will divide by 3. Like I don't want to choose 2 because then I'd have like negative 2/3 plus 1. Or if I choose 1, negative 1/3 plus 1, that's just going to create a fraction as my y value. Not very favorable. So that is not a great strategy to have, just to pull any sort of x values to plug in here. So I'm going to use x equals, let's just do negative 3 because that's divisible by 3. Let's use 0. And then let's use x equal to positive 3. So x equals negative 3, so that's going to be negative 1/3. So we have negative times negative 3 over 3 plus 1. Careful there. That is negative of negative 3. The opposite of x, the x is negative 3, so that's going to become positive 3 over 3 plus 1. 3 over 3 is 1. 1 plus 1 is 2. A little tough one there. Negative 3, 2. Next one. Negative 0 over 3 plus 1. So that's just going to be 0 over 3 plus 1. 0 divided by 3 is 0. 0 plus 1 is 1. So that's just going to be 1. So 0, 1. And last one, 3 again. But this time it's going to be the opposite of positive 3. So negative 3 over 3 plus 1. Negative 3 over negative 3, negative 3 over 3 is negative 1 plus 1, which is 0. So that one is going to be 0, so 3, 0. Let's go ahead and plot these points. Negative 3, 2 is right here. 0, 1 is right here, and 3, 0 is right here. And if an equation is in standard form, and you're graphing and it's not making a straight line, then you probably have to go back and check your ordered pairs. But everything's checking out here so far. And that's not going to make a straight line. Oh, not too bad. Not great, not bad. Next scenario, y equals negative 3 and x equals 3. So I want to do these on the same graph and talk about this. So y is equal to negative 3 and x is equal to 3. So all it's saying here is y is equal to negative 3. If I go to graph that, I don't have any x values to plug in. Like if I'm trying to create a table and I have x values, I don't have anywhere to go, right? I don't have any x values to plug in. So this graph, y equals negative 3, doesn't even exist where we would plug in x values. It has no x values. So what this looks like then, y equals negative 3, would just be a point where y is equal to negative 3, and it'd just be a line horizontal. That is not a horizontal line. Let me try that again. There it is. Okay, so it'd just be a horizontal line along y equals negative 3. Because it exists everywhere, y is equal to negative 3. So we just have a horizontal line along y is equal to negative 3. Now x equal to 3, think think about this one for a second. So x equal to 3. The only value for x that I could plug in that would make this a true statement is when x is equal to 3. 3 equals 3, yeah. So at the x value of 3, this exists everywhere where x is equal to 3, because that will make a true statement everywhere x is equal to 3. There it is. So x equal to 3 is a vertical line on the x value of 3, because the only x value that I could plug in to make that a true statement would be 3. So if I had like the point 3, 5, or 3, negative 10, or 3, negative 100, or 3, 150, it doesn't matter. That graph is going to exist because it's x equal to 3. So it's saying wherever x is equal to 3, that is my graph. Same thing over here, my y value of negative 3. If I had the x value of like negative 2, negative 3, 0, negative 3, 3, negative 3, it doesn't matter. That y value is negative 3. So all of these points, 0, negative 3, 3, negative 3, all of those will exist along that line, that horizontal line, for y is equal to negative 3. Same thing with x. X equal to 3, it's going to be a vertical line. So all of those points exist there. So those are good examples there for y is equal to negative 3 and x equal to 3. So you can see the relationship on how those react to order pairs. I think I just have one more example. The number of firefighters Y in thousands in the United States can be estimated by the equation y equals 500x plus 6,045, where x is the number of years after 2019. Create a few data points. Use the equation to predict the number of firefighters in the year 2029. So if we were going to graph this, we want to create a couple of data points here. So we would take, so the years after 2019, so we could just say x equals 1. That'd be 1 year after 2019. We could say x equal to 2. 2 years after 2019, x equal to 3. 3 years after 2019, and then we would just take those values and plug them in. So x equals 1, 2, and 3. And that would be y equals 500x plus 6045. So x equal to 1, so that'd be 500 times 1 plus 6045. So that'd just be 500 plus 6045, which would be 6545. Let me just grab a couple points here and then we'll discuss the results. So 500 times 2 plus 6045. 500 times 2 plus 6045 should be 7045. And x equal to 3, so 500 times 3 plus 6045. $75.45. Now I don't have a graph for this because the x and y would be just kind of hard to navigate, but I want to talk about the answers before we answer the second question here. So when x equal to 1, that means it's 1 year after 2019. So 1 year after 2019, this is projecting that there will be 6,545 firefighters. 2 years after 2019, this is projecting that there will be 7,045 firefighters 2 years after, and so on. So we could graph that. You just, create a graph from that. But let's do letter B. Letter B is asking us to predict the number of firefighters in the year 2029. X is the number of years after 2019. So if we're trying to predict the year 2029, you have to think about how many years is 2029 after 2019. That means we are going to plug in x equal to 10 because it is 10 years after 2019. So I'm going to do y equals 500 times 10 plus 6045. And then that will be our prediction 10 years after 2019 based on this model that we have here. So 500 times 10 plus 6045 is 11045. So in the year 2029, there will be 11,045 firefighters in the year 2029 based on this model that we were given here. So good application to graphing.